Hello there, Steven here. Today I'm going to give an introduction of WebSocket. WebSocket is a communication protocol on the transport layer, similar to HTTP. We're going through the main idea, features, connection process, where it is used, its drawbacks, and the future for it. The main idea is this TCP connection in HTML5 that is going to allow bidirectional communication. Its features include the following. First, it is compatible with HTTP. WebSocket uses the same port as HTTP, and WebSocket Secure uses the same port as HTTPS, which means any firewall that allows HTTP will also allow WebSockets. Second, it's low overhead. It uses a single TCP connection, and it uses a very small header, as we'll see later. It's also full duplex, so the server can push information to the client. The connection process is composed of 3 stages. First, we have the opening handshake. The messages were sent. When it's closing, a closing handshake is performed by each side sending one close frame. The opening handshake consists of the client sending a normal HTTP 1.1 request, shown here. Notice that WebSockets are just like HTTP, so they use URIs as well. The client needs to specify upgrade and connection upgrade to let the server know that it wants a WebSocket connection. The server should respond 101 switching protocols, and then the connection is upgraded. These 2 keys are for security validation. Messages is the units of data transfer. For security reasons, we mask payload from the client and not from the server. And the following is the WebSocket framing protocol. We have the theme, reserved, opcode, mask, payload length, extended payload length, masking key, and the payload data. The opcode is a 4-bit operation code to specify the frame type, ping or pawn, or connection close, used for the close frame. The mask specifies whether the payload data is masked. If it is masked, masking key should be 4 bytes. Otherwise, it doesn't exist. Payload length is 7-bit, but if it is 126, the following 16 bits are used as an unsigned integer to specify the payload length. And if it's 127, then the following 64 bits are used. This means we could potentially have 2 to the 64 bytes content length. The header is small. It can be 2 bytes if the payload is under 125 bytes, which has overhead down to 1.6%, and is also very low overhead for medium-sized payload. WebSockets are good for anywhere HTTP AJAX requests are good for. It connects the server and the client and allow them to communicate continuously. Here we show an example of Phoenix Live View and Ruby on Rails Hotwire. First, this is the Hotwire app, and if we click on new comment, it is going to update part of the DOM, but it's going to send a full HTTP request. As we see here, it's 3.36 kilobytes. And if I make the comment, it sends another request. Now this is the Phoenix example where we have this dashboard where it shows the memory usage. If we inspect, we can see that we have 2 WebSockets, and this WebSocket is for the dashboard. Every second, the transfer size grows. However, no new connections are established. If we look at the headers, it is exactly what we've seen before. Back here, we have some drawbacks as well. WebSockets are stateful, which means the server has to store all the states, unlike using HTTP. So the complexity is high on the server. It is also tricky to deploy, according to some Python developers. In the future, we'll see more adoption of WebSocket in the server-side interactive frameworks, such as TypeScript's remote procedure call and AJAX, which is a markup for AJAX requests. The frameworks would do the heavy lifting and hide the complexity from its users. For example, Phoenix allows the users to run one command and get the full WebSocket running. Thank you for watching. I hope you learned something.